Okay. So as you see, actually, we still are in the simulator over here as we finished last session.
Yeah.
So in this session, I'm gonna start the oscilloscope for you, which is from this icon.
Mhm.
And I fixed and pinned in this part of the page the scope. As I mentioned, actually, you can pin it anywhere. You can drag it and pin it anywhere. So I just pinned here in top part, okay?
Mhm.
Or you can drag it and put it in the middle part like this. So it's
Mhm.
really flexible. You can do it anywhere and you can pin it anywhere. So in this case, actually, I choose the VP speed as we explained earlier last session and axis 0. And
Axis.
then a couple of the settings, XY mode, XT mode, which is the 2D mode for plotting. And also I used the continuous trigger mode. I used the manual trigger in this part, but you can also use the program trigger. I will show you. Because of the manual trigger, I need to start from here, so it will start plotting by this. I can change the scale from here while it's plotting. You see the line actually plotting here. Okay, so if I run this program, you will see I have the wait idle. As I mentioned, the wait idle actually at the end of the target position, it goes to the zero. I mean, the speed goes to the zero and then start the next point. So let's run this. Let me scale it a little bit better. Okay. If I run this, you see here?
Yeah.
Okay. So let me. Okay, the speed actually is too high, so I can reduce the speed a little bit, like 2, for example. So if I run the program again, I can scale it.
Yeah.
You see,
Yeah. You can see.
this is the 2 RPS, and it moves to achieve the 1010, and then we'll go to the next step. So if you see, you can find some interrupts, and the speed goes 0 and then start again like this. You see,
Yeah.
and this is the
Stop or
wait idle actually. The wait idle makes speed 0 at the end of the target position and then start it again based on the accel and decel. Okay.
cell. It's very high acceleration.
Yeah. So I can reduce the acceleration like this, and you see better ramping for the start and stop. Okay. So let's do it again. You see, it's
Yeah.
getting you know more ramp. I mean, the timing is
Yeah.
more than before.
Stop fast.
Exactly. If I increase the speed a little bit, like 5, you see the jumping on the speed. Yeah,
Yeah.
it shows better. There are a couple of options you can, for example, change on the scope on the display. There is an option here we call setting. Okay, you can go from here or you can choose it from here. This option. So in the setting, we have a part called viewer. On the viewer, you can you have a couple of parameters to set here. For example, you can the trigger position cursor. You can increase the width, so it will plot a thicker lines for you instead of the narrower line like this. So if I just change it to make a difference, like 6 or 7, like 10. if I start the plotting, if I run the, oh, sorry, I think this is not the case. That's the cursor. So the line is another parameter. This is the cursor, this is the traces. So for the first one, this is the color, and this is the width, sorry. So this is the line width.
Oh,
To make it more visual.
okay.
Okay. So if I run it,
Yes.
you see it much clearer. And you can do it now for cursor as well. Now, what I want to show you is if I remove this wait idle by comment them out like this, like this, like this, and like this. And I can change the speed. For example, I can start the speed equal 2, for example. And then in this section, I can change the speed and make it 5. And then I can make the speed equal 8, for example. And at the end, I can return the speed to 2, okay, to make some difference. I can validate it because you see, once you change anything on the program, actually it will come up with the compiling question mark. So you can click over here to compile it, or you can use this option to compile it, or you can just run the program. If it will compile it at the beginning, and then it will run it. So it's kind of the automated process, but you can do it manually also. In this case, I removed the wait idle command from here and I changed the speed, so you will see what happened. The difference actually will be clear here. There is no 0 speed anymore. It will go directly from the existing speed to the next speed when the position, achieved. Okay, hold on. What's going on? Pause. Okay. Oh, you know what? Actually, I just changed the speed, and this changed the speed for axis 1. Okay, so what I need to do is, because this is a single axis move for us, okay? So I can comment it out like this to make it more simple. So it's a base 0 only now. Then this command actually will target base 0 only. Okay, now if I run it from here, now also run it from here, you see what will happen. Oh, you know what? Actually, because it's processing so fast. Oh, okay. The point is, that's a good situation. Actually, it shows how fast the speed changing, because this is happening in milliseconds. So all speed apply at the same time, basically. Okay, because there is no wait idle here. And finally, the last speed will be the one using and plotting over here. So if I bring the wait idles, just to show you what happens, okay?
Yeah.
Now the speeds will apply because we use the wait idle. But still we have, you see, we have zero speed at the end. and the next split apply after, you know, applying the second target position, like this. Okay, so this is what I want to show you in terms of the movement plotting. So you can do the same, you can activate the other channels and then show the other channels, whatever you want, include, you know, let me stop it, include all the options over here. You have for the axis parameters, you have many options here. You can choose following error, you can show the draw following error, you can show axis status. Lots of parameters actually are available here. What you can also plot here is the digital input and outputs. Okay, so in case of the digital output, you need to choose the out from the menu, okay? And you can go from the channel and choose the out, and then type in what channel. Channel 0 will be digital output 0, channel 1 will be digital output 1, and so on. You can also display the digital inputs if you go to the channel and choose the input. Okay. How to display it? Let me show you. You have an option here, digital I/O status. Okay, you can display it, and the same as this menu, this window, you can drag and pin it anywhere you want. I just pin it here based on my habit. So you can also activate and deactivate the digital input and outputs from here. Okay. So out 0 is supposed to be this one. Okay. So if I plot the digital output 0 over here, which I choose, and pick the manual, okay, and run the scope, you will see if I turn it on, it will display with the blue because it's supposed to be plotted in the blue color. So this is a very good tool actually if you want to display a moment of the activation of the digital input, for example, which is combined with the position control, so you can, you know, plot the moment, and then you can do the troubleshooting if something happens, you know, unusual. So the digital input and outputs, as you see, also can be on the plot as well. You know, you can have it. Any question?
No.
Yeah. If you need more data about the oscilloscope, you can go to the Trio base. Basically, you need to go to the Motion Perfect help over here. This is the different help than the Trio Basic help, because the Trio Basic actually show you the functions and the commands just like as you use a manual. But if you want to know more detail about the software itself, I mean the Motion Perfect, you should use this one, which is the specific help for the Motion Perfect options, include the oscilloscope. If I open it up here, you will see it will pops up. So if you want to looking for oscilloscope, you should go to, I believe, to the main window. No, it's in the tool and oscilloscope, and here you can get some references. So all the options are here, include the setting, as I mentioned to you, so you can see all the details. Okay. Okay, so if you're good and there's no question, I can move to the next step, to the HMI. Is there any question?
No.
Okay, good.
Continue.
So let's go and create an HMI program. As I mentioned to you earlier, this software is supposed to handle the programming of the controller and programming of the HMI. So we can do the HMI programming in the same software environment. How to do that? Actually, you need to go to the file, program, and create a new file. And then from this option menu, you can choose the HMI design, okay? And give it a name. I give name of the HMI just as an example. And you see in the product tree, it asks you, because in the tree actually we have 7-inch and 10-inch, two options. And also dependent and some other options. So we choose the first option, which is by default. The program of the 7-inch and 10-inch are the same because the resolution are the same. It's just a matter of the size, width, and the height of the HMI. That's it. So once you create and choose the HMI, actually it will pop up here a new option which shows the HMI option. If you right click over here, you can add a page. As a page, it should have a name like PG1. Okay. So once you create a PG1, which is the page 1, it will give you this environment. Let me just decrease this part and expand it a little bit. Okay, so this is the HMI environment for you. We have different options here. The most important options are objects that it listed over here in the left side. For example, if you want to have a button, okay, you click on this, drag it, and put it here. So this is supposed to be a button for you. Because of the configuration of the HMI, it's very flexible. The HMI actually, anything you program as a HMI in this environment will reside on the controller memory itself. So the controller actually will be the spot keeping all this data and the HMI programs for you. What happened? What you have on the HMI, actually, Trio HMI is just like a display, a touch screen display for us. So once you have the HMI hardware, and once you create a program as a HMI in the Motion Perfect and download into the HMI, it will send an application, a compiled application on the HMI, which will run on the HMI by existing application that we already installed on the HMI before supplying to the customers. So this application needs this compiled file from the Motion Perfect to run it on the HMI, and everything happens automatically. So you don't need to do anything on the HMI special. You just need to create your project and then download it by using this button. Upload it actually into the HMI. And once you have the HMI power on and connected by Ethernet cable to the controller, actually it will transfer the program through controller to the HMI. So the controller is just like a gateway because you'll always connect to the controller, not the HMI directly. Okay. And then okay, so let's create a button here. If you right click on this object, you will see a text like button. I can change it, like for example, if I want to assign the output 1, I see out 1, okay, or output 0. Basically the first output is the output 0 because I just start from 0. And then on the click, because this is a button, actually we need to create something to activate the output 0. And there are a couple of options here. You can use it. Let me explore something here for you. So we have the set variable. You can set a specific value on a variable directly. You can use this button to change the pages on the HMI by using this option. This is kind of fancy. You can write a code directly on the HMI. It can be an AnyMotion command because, as I mentioned earlier, this is residing in the controller memory. So all the options you have on the program, I mean the motion controller program, also available on the HMI. So you can basically run a move command like move 0 or move 10 axis 0. This axis 0 is to specify what axis you want to apply this move command. Okay, the same programming, I mean the same structure you can use also in your motion control programming. Instead of choosing base at the beginning, actually you can specify each line with the axis number. So you specify line by line that the commands goes to which axis by typing axis number like axis 0, axis 1 at the end of the command. Okay, make sense? And then yeah, but now I don't want to use this option, so I skip it, and I'm supposed to activate the digital output. So I go to toggle, for example, okay, because I'm supposed to toggle something, and then if I click here, it pops up digital I/O for me, okay, okay, and you see the OP1 or OP0. OP0 actually is the output number 0. This is the way we address the digital outputs in Trio controller, okay? OP0 and then click. So I can toggle the OP0 by this button. That's it. So I go and compile it, which kinds of validation. It said HMI validation detect no error. So it's already compiled, and then I will, if I have a physical HMI connected, I will download it, which I don't because this is a simulator. So I go ahead and run the simulator, offline simulator over here. Because I have the status of the I/O here, so it will display, you see, the output activate, and if I click again, it will deactivate because it's supposed to be a toggle. Okay, so yeah, this is kind of the sample input output activation by HMI program or by a button on the HMI. So let's do some movements also on this button. So what you can do is you can add more commands and assign it to the same button. As you see, here is the option, click to add a new action. So you can provide multiple actions to the same button in the HMI. So in this case, I just want to execute a command, and the command would be move, for example, 25 axis 0. Okay, then validate and compile. Again, there's no error, and once I open up the simulator, I have the button, the same button, but with the new function that will move the axis to target 25 unit. So if I click on this button, you see it will start movement over here. It not only activate the digital output 0, but also move the axis 0 to 25. You see that? So if I click again, it will disable the digital output over here for me, but it will apply another incremental move on the axis, which move it to 50 instead, because this is supposed to be incremental movement. It's deactivated here, but it makes another move command, and you see the buffer, the move buffer actually shows the move command. Target is 50 because it will add 25 increment to the existing position, I mean the current position, which was 25. Okay. what I can do in top of that, I can use a read-only text, because this is supposed to display something for me. And I can right click on that. And if I want to display something here, there is a option here, click to set data pending over here, okay? So I can bind the data to this object, and it can be the access parameter from here, okay? And what I'm gonna display is dpos or mpos. Actually, the mpos and dpos are the same. So let's choose the mpos, access 0, okay? And then you can set up the format. It can be text, it can be integer, it can be real. So I choose real. So the real is a floating point, so it will show also the decimal point and the numbers after decimal point to you. Just in case if you have, 4 digits after decimal point, for example, for kind of precision. And that's it. And then again, compile it. Let's choose base 0, and let's def pause 0. So we reset the position, the current position, just to make a fresh start. And then if I open up the offline simulator, it will show a number and also a button. So once I activate the button, you see exactly the mpos reflect here for me. And it will stop on 25, just like here. If I click again on that, so it goes to 50. So basically we create a numeric display on the HMI. It can be also a numeric entry. If let's stop it. If I do like this, if I go to the program, okay, and instead of move 10, I can use VR10, VR0, for example, which is the internal variables for the controller, okay? If I choose VR10, VR0, VR1, VR number 2, and VR number 3 over here. So instead of having a fixed number, now I set up a variable for that. So this variable can be accessible over the HMI for us. So I can go to the HMI page over here, and instead of a display, I can add more options from the editable text option, okay? So I can put some text over here, which define a numeric entry for me, okay? And then right click on that, bind a VR variable from here, okay? And it's by default it picked the VR0, okay, which is good for us. And I need to duplicate it, so I can copy this and create 4 of them, because we're supposed to have 4, okay? And I can align them like this, and then I can go to the same option and choose, instead of VR0, I can choose the VR1, okay? I can set it as VR2, okay? I can set it as VR3, okay? And in this case, actually, I can also have the VR viewer from here, okay? It will bring new windows up, that I can define a VR range to display here. So I can choose start at 0 and count for 3. So it will show VR0, VR1, VR2. Sorry, I need to go choose 4 because I have 4 VR variables. Okay, so I can type in the preset values that I need to be on the VRs, like 10, 20, 30, 40. Okay, so these are kind of the preset value that I can set it at the beginning of the program or whatever on the VR viewer option, like here. I can pin it also beside this one by putting here, okay, and sharing the same spot with that. And also my HMI are have new objects. I can validate the program and I can validate the HMI program, and then I can open it up. Now you see the same values that I entered here, so I can change it from here, like 45, okay, and it will reflect on the HMI directly. Or I can type something here like 39, and it will reflect the VR viewer. So there is a connection between these two that will update automatically the other one. Okay, so if I start from position 0 by def bus 0, okay, you will see what will happen. So, oh, by the way, actually this is a fixed command called move 25. So this is different. Let's start by the program from the beginning, okay? So if I go to the program page, and what I can do, I can, instead of this, I can go to the HMI and make a new button for executing the programs. I can put it anywhere. I prefer to put it here, and then I can get rid of this one. Instead, I can use executing command and run a test program. Okay, so I have a test program, so I can run it by using directly on the HMI and bind it into the bottom over here. Okay, once I do it, I can also change the name, and I can say run test. Okay, that's it. Validate, and then run the HMI. Okay, so the current position is 0. So if I run the program, it will run it. You see it? It's running. And then execute this program one by one, these steps. This is the last stop, which is the absolute movement. It will go to absolute position of 39, and then the program will be finished. As you see, it stopped the program automatically, because at the end actually it's open, so it will process one by one, and after wait idle for the last step, it stopped the program because there is nothing else at the end. I can loop it by some commands, like I can type in like while true, for example. Okay, I can make a while loop, and at the end I can type while end. Okay, so it basically make a loop for me, which will be an infinite loop because this is always true. So it will move for me forever from the top to the bottom. If I bring up the HMI again and set this one as 0 instead, okay, so it will a loop from 0 to 30 and then return back to 0. So once I okay, let's start by def pause 0, okay, which will reset the position from the 0 because the first, second, and third command will be incremental move, so I prefer to start from 0. And if I run the program, actually you will see it will go to the 10, then with the higher speed to 20, and then with the higher speed to 40, 60, sorry, and then return to 0. And you see the speed changing over here. There are lots of options here. You can display like speed, like any parameter. Actually, you can see what's going on. You can make it more, fancy by entering some, JPEG or, type of photo as a background, or make it colorful because this is a color display basically. So you see it's an infinite loop. It will go and return forever until you stop the program yourself. You can put a stop button over here, for example, or you can stop it from here, or you can hold all the running programs by this option, or you can stop motion from here. So I will stop the program myself and it will immediately stop, but the last move buffer still is active. See that? Till it ends, because it's already run by the program. It's already ran by program, before I stop the program. Any question?
No.
Okay.
No.
So
can we use real variables or protecting point?
What do you mean after real variable?
For move, for example, 10.533.
Oh yeah, sure.
Yeah? Okay.
Yeah, sure. Sure. Let me show you. If I go to PG, okay. Actually, it's a real because I just choose the. Okay, so the format type. I can change the real format over here. Okay. Yeah. The same for the others.
Okay.
So once you choose the real, it will open. It will open the option to enter a real value. So if I compile it, and it said it's already running. Oh, HMI content found. Okay. Now if I try to enter a value, I can put 10.58 like this. Okay. And then it will follow exactly what I commanded to be. So if I run the program, I can do something like this. I can put some breakpoints just in case, like this, like this, like this. It will make a better tracking of the program for me. So if I run the program from here, okay, because this value is not the real, so it's rounded up because it's bigger than 5. Okay, but what I can do is close this up. Okay, and then I can go to the PG, and this one I can also display 4 digits after decimal point. Okay, in this case it will display exactly the number with the decimal points for me. You see that? Now if I run the program again, okay, so I think I need to do is mpos label top left format real system properties, not this one. Format real integer text, which is correct, and then move. Oh, you know what? Actually, the unit is 1, so that's why it doesn't let me to move, less than 1. So it should be 1, 2, 3, 4, a real number. I mean, there's no friction number like that, I believe. That is why if I set a unit like 1.00, I think. No, why it doesn't display format number decimal point 4, which is correct. I will check it later. Why it doesn't display the exact, but it should be possible to show a real number also, just like a display, because it is exactly over here. Okay, VR0, and then the VR0 value is kind of the decimal point number. Okay, and I should see what it display here. See, display mpos as a number without decimal point over here. I think it's because of the unit, because unit is 1. So if I choose the unit, for example, 0.000 or 0.00001, okay, like this, and then I have the option over here. Okay, so let me fpos. Yeah, it's exactly because of unit. Like this, if I run the program, now the unit is with the 4 decimal points. So if I want to move it to the 10, I need to write a number like 1,000 or 10,000. Okay. And then run the program. What's going on? Oh, okay, it stopped somewhere. Again, there are move commands over here. Oh, you know what? The speed actually needs to increase. Consequently, unit is like this, so I entered 10,000 to, yeah, it's so slow. It moves, but okay, we will get to this point later. I'm not sure what's going on here, but yeah, there's option to do that. You can display, of course, the decimal points over here. I will check it later for you.
Okay. Yeah. No
Okay.
problem.
Yeah, no problem.
Okay, so any other question?
No.
No.
Okay, so let me stop